Hello, universe. So I'm currently available to take students in math and physics. I can teach any or most undergraduate math and physics courses. I would prefer to teach classical mechanics, quantum mechanics out of Griffiths, electrodynamics out of Griffiths, as well as tensor-based electrodynamics. I can also teach general relativity and advanced quantum mechanics out of Sakurai. And then on the math side, I can teach all levels of calculus, linear algebra. I'm actually writing a book right now on linear algebra, which will be done probably by the end of this summer. And then differential equations, partial differential equations, I can teach at the undergraduate and graduate levels for PDE. ODE probably just at the undergraduate level, although I have studied graduate dynamics, so I can teach out of dynamical systems. In particular, Chaos Theory and Nonlinear Dynamics by Stephen Strogatz is a book that I've studied thoroughly, as well as I've covered advanced. I did a reading course in ergodic theory and dynamical systems and gave several lectures for that, which are on the lecture notes are on my website, mathsheets.com. I'm also available to tutor real and complex analysis at the undergraduate and graduate levels. I can tutor undergraduate algebra and topology, also graduate manifolds, and undergraduate differential geometry. Probably not graduate differential geometry yet. That's what I'm currently studying. I'm self-studying that over this summer. Although I did complete a reading course from DeCarmo in Riemannian geometry, but I'm currently kind of improving my knowledge of the subject because my geometric intuition is quite limited. And as a tutor, I really like to focus on geometric intuition. I expect my students to essentially prepare themselves on a weekly or bi-weekly basis by doing certain readings, and then we can discuss those readings and the proofs of the theorems. I really like to focus on geometric intuition and understanding the concepts and the motivating ideas and key ideas behind proofs, because a lot of times, you can read a proof and you can read it line by line, and that's an important skill to learn, is understanding a proof line by line, each step of the calculation, right? But then there's a bigger picture, kind of unifying the proof as a whole and taking a step back and looking at the key ideas and the motivating intuition behind the theorem. So how did this person come up with this theorem? How did they develop this idea? What's the geometric intuition behind this, right? And that's really my focus. And I'd like to kind of emphasize that in our tutoring sessions, right? I want my students to build intuition and understanding of concepts and ideas rather than just being able to complete an algorithm and get the correct answer, okay? Completing an algorithm and getting the correct answer at an earlier stage, for example, when you're just learning calculus or differential equations or linear algebra or even partial differential equations. And on the physics side, when you're first learning electrodynamics and when you're first learning classical mechanics, it's very calculation oriented. Given a functional, find the Euler-Lagrange equations, compute the Euler-Lagrange equations. But once you have this system of Euler-Lagrange equations, how do you then study that system, right? And in many instances, certain physical phenomena and dynamical systems will exhibit chaotic behavior. And so there's a lot of qualitative descriptions of the physics behind these differential equations and a lot of geometric intuition involved. And a book like Stephen Strogatz, Nonlinear Dynamics and Chaos Theory, is a great example of the kind of intuition that I'm talking about, the kind of geometric focus that I like to prioritize. I think Strogatz did an excellent job with that book. And I think he covers a very advanced topic at a level which is approachable for an undergraduate student who doesn't have a ton of background, right? So anyways, and then the other math subjects that I can tutor undergraduate algebra. I think I probably mentioned that. And yeah, pretty much, if you have a course, also statistics. Yeah, statistics and probability. I've taken several statistics courses and I do probability and measure theory when I study optimal transport. So I have a decent background in statistics and data analysis with Python. Um, so yeah, if anyone's interested, feel free to shoot me an email. I'll attach my email to the description, and we can discuss pricing options privately. But yeah, I hope you all have a great day, and I'm excited. I hopefully, I love tutoring math and physics, and hopefully, this will be beneficial for everyone involved. All right, have a nice day.